I want you to think back to September 9th, 2020. An alarm goes off. You check your phone and it says 8 o'clock, but that can't be right as it's still completely dark out. You step outside to investigate and see a thick layer of smoke blocking out the sun. As ash rains from the sky, it might be the first time you think, man, I sure am happy to have this mask on. Or perhaps, I guess the Mayans were 8 years too early. But in the very least, you think, this is not normal. And you'd be right. 9 out of 10 of the largest wildfires in the history of California have all occurred within the last decade. It's understood that there's a wildfire crisis going on in the West, but where the question remains is as to what is causing this crisis in the first place. So let's return to you standing on that sidewalk, taking in information, and trying to explain what in the world is going on. You notice that the air around you is rather hot and dry, and you think back to last night as your window rattled because of the exceptionally strong winds. You might think to yourself, maybe warm temperatures or dry air has an impact on wildfire, and for sure extreme winds do. Now, what if I told you I'm using the same method to solve this problem, but with an artificial neural network, which is a fancy way of saying teaching a computer to think like a human. The neural network takes in information, applies weights to the variables, and creates an explanation or prediction for some kind of phenomena. And not to scare you too much about any future war against robots, but machine learning does have some pretty significant advantages. First, in order for you to have the same amount of data as what I'm training my model with, you would need 150,000 clones of yourself, evenly spaced throughout California, taking weather measurements every hour for the last 30 years. Now, that's probably doable, but then you'd have the problem of analyzing all this data. It'd be easy if for every degree in temperature you went up, 100 more acres burned. But in reality, there are no simple solutions. This isn't just a problem with you, but is actually a limitation to the traditional methods of science. While logistic regression tries to draw a straight line through the data, artificial neural networks can map out the exact complex relationship. Your final problem would be figuring out which variables played the biggest role. Perhaps temperature caused 10% of the fire growth and winds 50, but maybe the exact opposite is true. With a neural network, you can isolate your variables to see what percentage of the acres burned they were responsible for. With this knowledge, we'll be able to more accurately warn the public about fire danger and more efficiently target our wildfire and fuel management resources. Right now, an alarm is going off, but we will remain in the dark until we can identify the key contributors to this problem so that we can get one step closer toward prioritizing a solution. Thank you.